So, good evening and welcome to my talk. So, my name is Muharem Hrnjadovic and I work for Rackspace in Switzerland. And I'm not a magician or soothsayer, so I can't really see the future. Okay. Nevertheless, I'm of the opinion that there will be OpenStack in your future, and I want to explain why, and why you should be paying close attention to it. So this is potentially a very boring talk, and in case you fall asleep before we reach the end, so these are the points I would like to take away from the talk. So this is the too long did not read list. So number one is that cloud computing is the future of our industry. And number two is that the cloud that eventually wins will have to be open. And number three is that OpenStack is the future of the open cloud. Okay, so my first contention is that cloud technology basically turns IT upside down. Okay, so people ask this question: is cloud computing another one of these fashions? This is the fashion guy on the left-hand side. Yeah. Or is it something really substantial, fundamental that we need to pay attention to? Okay, and how many of you do use a cloud actually? Okay, so quite a few. So basically, I don't need to preach to the choir here. I think it's pretty clear at this point that the cloud technology is really turning IT upside down. And just by way of perspective, so how many of you have seen this diagram? Okay, so it's new. I'll speak briefly about it. Okay, so there's there's three curves here. So this staircase here, the staircase here, this is the so-called lose-lose proposition. Okay, so basically, whatever you do, you lose. Okay, so this is how people used to build data centers. So they would deploy 10,000 machines and hope it's enough. Okay, and then you see here so the red curve is the actual demand. So you see here the actual demand is below the capacity. So you're losing money. So you deployed a big data center and you deployed more capacity than you needed to do. And here, the actual demand exceeds your capacity. So your clients or customers are very unhappy, and you're losing again. You're losing customers. Okay. So this is the lose-lose proposition. Okay. So do you want to be in a losing business? Yes or no? Hopefully no. Okay. So this is where elasticity comes into play. So this green curve is sort of the holy grail of IT. Okay. So what you would like to do is you would like to have a curve, or you would like your elasticity to shadow and mirror the actual load. Okay. So if your actual load goes up, like here, you want your green curve, your capacity to go up as well to meet the demand. And if it goes down because it's weekend or whatever, you want your capacity to also go down. You want machines turned off to save cost, electricity, and save the world, and do all the good things in the world. So this is something that cloud computing enables you to do: elasticity. Okay, so just to sum it up, so what the cloud gives you, a public cloud at least, is sort of infinite scale and elasticity. Nothing is infinite, but let's say a public cloud has way more resources than you're likely to consume. It's pay as you go, so you don't need to sink $250,000 in a data center. Do you hear me now? Okay, cool. So what you do is you consume cloud resources, and at the end of the month you get a bill. You pay a bill. It's basically a utility. It's not capital expenditure anymore. It's operational expenditure, and it's self-service. So you don't need to wait for anybody. You go to some kind of administrator and say, "Hey, I need 10 new servers." He says, "Go away. I hate you. I don't want to see you." And then 3, 6, 9 months, depending on how fit your IT organization is, you get the service. There's no need for that. Basically, pull out your credit card and you basically get what you need. And in order to be successful in this new world of cloud computing, you obviously need to make use of automation. So what you get is a data center with an API. Okay, how cool is that? So why this free and open thingy? Okay, so why sort of can't we have a cloud which is closed and opaque? Why do we care about this? It's a strategic resource. Like electricity is a strategic resource. Like if you don't have power, we sort of host, we can't do anything. How about internet? If you're somewhere where you don't have internet, again, you can't do work properly. So for many organizations today, and even more so in the future, the cloud will be a strategic resource. Okay? And if it's strategic, it's important, and then it's important for it to be open. It's a bit like Linux, okay? Like a Linux kernel. If it's an operating system you use, you want it to be open. You want eyes on it. You want people who are competent to look at the code. Just make sure there are no backdoors or no surprises in that code. Okay, so the other advantage is if it's open, you can innovate and around it and do research around it. And if you go to universities, to students, master students or PhD students who do like research around cloud these days, they don't do research around Amazon's cloud. There's no research to be done. You can't. It's all closed. Okay, but they can do research around OpenStack because it's open. They can look at it. They can modify it, tweak it, improve it, and do whatever they please. And last but not least, have a look at some of these companies here. They're all part of the OpenStack Foundation, of the OpenStack ecosystem. Okay. Do you see the Salvation Army somewhere here? So these are all commercial corporations. So it's about money, about turning a buck. Okay. So why are they so keen on pursuing OpenStack? Because it's an open platform. Okay. It's an open platform. We all collaborate around OpenStack, but we all leverage it to turn a profit, to make money of it. And this is something that you can only do with an open platform. Ecosystems sort of come about and live around open platforms. So here's a diagram that IBM put out like half a year ago when they decided to standardize on OpenStack. So like around the March timeframe, IBM came out and says, all our cloud efforts will be based on OpenStack, and we're investing like $1 billion in OpenStack. Okay, so I don't know whether you remember this, but like in year 2000 or 99, IBM already came out and said we're investing $1 billion into Linux. Okay. And that was a big boost for Linux. It was a big validation. If Big Blue is behind some kind of technology, this gives you a lot of credibility. Okay, and so here's the perception. Like why OpenStack? Why not, why not some other, why not like Nebula or whatever? Okay. So basically, here's the perception. They said, okay, on the left-hand side, you have the like the development curve of Linux. On the right-hand side, you have the development curve of OpenStack. Basically, it's taking off like a rocket. So this is like a case of standing on the shoulders of giants. So all the people who are in the OpenStack community basically learned from the Linux community or from other open source communities, and basically did all the right things. They bootstrapped an OpenStack Foundation, introduced open governance to the project, made it all open, made it like a level playground, and they fostered this community that erupted around OpenStack. And this is what attracts other companies. And where they see like the best chance to compete in the cloud space in the future. So here's a couple of figures I want to show you. I don't have any Havana. So Havana was just released today, together with Ubuntu 13.10. So these are some of the figures from the previous release cycle of OpenStack. So OpenStack is released on a 6-monthly basis. Okay? So in the previous cycle, we had 517 contributors. Now think about this figure. So this is a Python project. So all these people are writing Python. Okay. So think how much damage you can do with 507 Python devs. Okay. That's a massive force. Okay. And they're all working here. You can also see the growth. how the project grew. So these are like the last 3 releases. And you can see that in a Grizzly release cycle. Short commercial break. Time to cool off or something? Oh. You know how long it takes?
How many times I pressed?
Yeah, so maybe while we wait for the projector to come back. So the kind of process and the development of OpenStack was modeled after Ubuntu. So many of the people who were like leading the OpenStack project in the beginning were former Ubuntu guys. So this is where the OpenStack developer summits come from, where the 6-month release cycle comes from, etc., etc. Also blueprints. So the last OpenStack developer summit was in Portland in April of this year, and it was so the space accommodated like approximately like 2,200 people. So and like then like 2,500 people came to the summit, and so they could accommodate like another 300, and they had to turn away people. This is like the popularity of. Thanks. Yes, the green button. This is how popular it is, and like so the next developer summit will be in Hong Kong, and the estimates are that it will see 4,000 participants. Yes, thanks. Okay, so another metric I want to show you is the community growth. So there's a person here, and like after each cycle, he would basically go through the commits and basically evaluate statistics. And what he also does is he compares the communities, the communities behind the various open source clouds. So we have a Cloud Stack, we have Open Nebula, we have OpenStack, and we also have Eucalyptus, which is like an AWS clone. And so according to his findings, so what you see here is this is called the hockey stick curve, this blue curve. Okay, so this is what gives like wet dreams to venture capitalists. Okay, so if you go to like if you want to like start a startup, and if you, in your business plan, you can sort of show him that your business expects such a growth, it's a done deal. You're in. Okay. So this is the growth of the community, of the OpenStack community. This is the blue curve. This is the hockey stick graph. Okay. And these are the other communities. So what you can see is, and this is like a qualified community measure. This is not just people who appear on the IRC channel once and then never come back. So these are people who are like collaborating, working in the community. Okay. So where are these devs coming from? So these 507 devs, like what kind of people are these? Are these hobbyists who sort of sit down in the evenings and hack OpenStack for half an hour? No, it's very similar to Linux. So all of these people are employed to do OpenStack work. Okay, and so this is the breakdown of who these people work for. So and so it's Red Hat, Rackspace, IBM, HP, Intel, VMware, Canonical. I mean, it's basically like a bit like the who's who in the IT industry. Okay. And why is this important? Well, this tells you that the project is maintained at a fast clip, at a fast pace. Okay, so features are added fast, and if bugs are identified, they will also be fixed in short order. Here's a couple of other metrics. So job trends. Again, this red curve looks like a hockey stick. So this is the demand for OpenStack experts in the market. So if you want to land yourself a cool job, start playing with OpenStack. So on the right-hand side, we have like Google search trends for OpenStack. So again, this blue thing taking off exponentially, these are the search queries for OpenStack. So this buzz, there's like mindshare in OpenStack. And again, like why is this important? Well, if you want to get into it, if you have a problem, if you want to learn about it, it's important that people are writing blog posts about it. That people are talking about it. That there's an IRC channel you can ask questions. There's a mailing list. There's videos about it. Okay. So, depending on how you count, OpenStack today is maybe it's slightly above 1 million lines of code. And again, this is Python code. Okay? So, I think it's not too far-fetched to state that OpenStack today is the biggest and most important Python project that we have. And I would say, it stands to reason that we should start, like everybody should start paying attention to it. So I won't go through the components here, but I mean, you'll find the usual services the cloud supplies. So you have the compute, which is similar to EC2. You have object storage, which is similar to S3. You have an image service. You have block storage, identity, etc. And so this is not all. I mean, there's a whole plethora of upcoming projects that are sort of pushing to become part of OpenStack. Okay, so what the OpenStack Technical Council is doing is basically it's sort of pushing people away, saying no, you can't become part of OpenStack. No, this is too much. Okay, so all of these projects actually pushing, they want to become part of OpenStack. Okay. And there's a process that the Technical Council and the Foundation put forward that outlines how a new software component can become part of OpenStack core. And so the top two components, heat and accelerometer, which are in charge of orchestration and metering and monitoring in OpenStack, are going through this process right now. And actually, the top three, Marconi is part of it as well as Trove. Okay, so you see, like this thing is very, very vibrant, huge community, a lot of software being written, people pushing to add new components, new important components to it. So again, why is it cool? I'll start at the bottom. It's Python, okay, and this is the Python conference, and it's a very fast-paced project. It's a great community. So and it's also a very welcoming community. Strong ethos, strong behavioral codex. So like I read the mailing list regularly. I look at IRC channels regularly. I see people coming and say, "Hey, I'm a newbie. I don't have a clue. What can I do?" Basically, there's a place for everybody. Very welcome. Okay, so what's in for you? Well, as a developer, you can look at it, you can learn from it. It uses great technology. Basically, whatever is interesting and cool in Python land is being utilized in OpenStack, and you can land yourself a job. So if you sort of take interest in any one of the components, start looking at the bugs, the blueprints, get a commit or two in, it's very likely that at some point you'll get a job offer. I mean, so there's so much work to do in the project, and these companies who are pursuing it, who are part of the foundation, are constantly on the outlook for good people. If you're a user, well, you're a user who wants to pick an open source cloud. You obviously want to pick a cloud that has a lot of mindshare, where there's a lot of other people using it, a lot of other people writing about it, etc., etc. And if you're an admin in some organization, it's like, hey, I can have my own cloud. Screw you, I'll take OpenStack, deploy it, and be happy. Like, at least that way I can learn. Again, like if you look here, here's the community page with the jobs. I mean, there's plenty of jobs to be found. Here's a tweet, which is like a couple of months old. Basically, it says there's an estimate by that by 2015, which is basically just around the corner, okay, there will be 14 million new jobs in cloud computing. So this is sort of important. And just look at the OpenStack cloud, OpenStack job development. So if you sort of exclude everything else, if you just look at OpenStack, the number of job opportunities grew by basically almost doubled. I think at this point it just doubled. Okay, so I want to sort of zoom out a little bit and talk about talk a bit about the backdrop, of this cloud thing and IT. Okay, so there's some warning signs that you can see sort of on the horizon. So cloud technology has these three properties. It's an equalizer, it's a disruptor, and it opens totally new possibilities. Okay. So how is it an equalizer? Well, 10, 15 years ago, if you want to do something cool, you needed to have a lot of capital, a lot of money. These days, I mean, what's this startup that sold for $1 billion to Facebook? Instagram? Yeah. I mean, they were basically just chewing shoestring and chewing gum and a couple of cloud servers. Okay. So the cloud is a big equalizer. I mean, you can do like massively cool things just utilizing the cloud. It's a big disruptor. So when I went to the CloudCon, LinuxCon and CloudCon conference in Japan in May of this year, so the head of the Linux Foundation said, there's a study that says for every $1 spent in the public cloud, there's $4 that are not spent on data center center equipment. How's that not a disruption to this entire industry? Okay. So the cloud computing, public cloud, private cloud, whichever cloud, it's a big disruptor. It changes a lot of things in IT. Okay. And regarding the new possibilities, I will show you something on the very last slide. Something. So anyway, so whenever you see these three signs, okay, basically you have a revolution in your hands. Okay, and this is what we're actually seeing. Okay? Things are changing at a fast clip. Okay, and what is the most important things about revolutions? But the most important thing about revolutions is not to end on the guillotine, but to be on the winning side. Okay. So how can you be on the winning side when it comes to cloud? But there's a couple of principles you need to adhere to. Okay. So number one is, forget scaling up. Forget sort of buying bigger and bigger boxes and like exponentially expensive, more expensive boxes. Scaling out is the rule of the day. Basically, if you run out of capacity, you don't buy a bigger box, but you buy 2 more boxes, okay, and scale out horizontally. Okay. So what this means is, at some point in time, you're going to make use of a gazillions of machines. Okay. So and you can't sort of run around them and maintain all of them. So you need to learn how to automate. So all these funny tools that we have these days, like Chef and Puppet, etc. And what pushed these tools? I mean, what pushed them to the forefront? How did they become so prominent as they are today? Well, the cloud. Because in the cloud, we're talking like hundreds of servers. Yeah, whatever. Yeah. Salt stack then, Python, yeah. So basically, cloud is driving automation. So you need to automate, okay? So you can't have snowflakes. A snowflake is a kind of, each snowflake is unique. So a snowflake is like an idiomatic expression for a unique server. A server that you configured and sort of you're petting it and stroking it and blah blah blah. And then whoever did it left the company and nobody knows how this server is actually configured anymore. If you pull the plug and turn off the power, you just pray. You don't know what will happen. Okay. So we can't afford snowflakes anymore. Obviously, all our servers need to be configured in automated fashion. The configuration must be somewhere in a repository, accessible, documented. Everybody needs to know. It needs to be shared, etc. Okay. And no more pets. Okay. So we need Kettle. So this is a figure of speech that came out of CERN. So a pet. If you have a dog, if it gets sick or whatever, you take it to the veterinary, you take good care of it, and etc. etc. And if you if you've heard of 100 cows, one of the cows gets sick, you just slaughter it, bang, you get 10 more cows, okay? So this is the cloud world. Okay, so all the servers in the cloud, the Kettle. Okay, if one virtual machine gets stuck or hung somewhere, just kill it. Bring up 10 more. No problem. No big deal. So that's it. This is the era of Kettle. Okay, another thing to do is basically, doesn't look like fun. Okay. Well, we leverage like industrial strength systems, a strong operating system, and automate. It doesn't matter what you use, Chef, Puppet, SoulStack, just learn one tool and learn to use it well. Okay, yeah, and last but not least, pick OpenStack. It's widely used, so there's knowledge out there. There's stuff, you can find people in the meantime who know something about it. It's very versatile. You can deploy it on one machine, your laptop, okay, or on 15,000, like CERN in Geneva. So it scales very well. You can deploy it as a public cloud, in private, just for yourself, or you can have a private cloud and burst into the public cloud if you run out of capacity. Okay, so this now is the crazy stuff I was alluding to. Okay, so this is a company in Germany, and they're manufacturing heater systems. So basically, when you want to build a house, you need a heating system. You go to them and buy it from them. The question: why is this guy talking about cloud on a Python conference, talking about Aotera, who builds heater systems? Well, it's something very unusual. Okay, so when they had to pick the source of heat, they chose servers. So they're not burning diesel here. Okay, so basically their furnace is a rack of servers. And guess what is running on these servers? OpenStack. And they're competitive. So if you buy like a heating system from them, you don't pay more money than from any other classic heating manufacturer. So, and this is some of the stuff, okay, that OpenStack and cloud and makes possible. And with that, I'm done. Questions, please.
Hello. So about these heating systems, are the servers located in like a customer house, or the heat is pumped via pipes?
No, they're locally. This is even cooler. But so you basically so this opens totally different possibilities. So they will operate the public OpenStack cloud, and there'll be like proximity measures. So if you want an instance, they can sort of spin one up close to you. So that's the story. Yeah, they are in the buildings.
Any other questions?
Hi.
Yeah, do hear you.
You showed an impressive collection of companies that support OpenStack.
Yes.
But I'm wondering how you avoid sort of politics coming into play when you've got so many different companies with competing needs.
Sorry, how do we avoid what?
Politics.
Politics. Oh, you can't avoid politics. No.
Okay.
So, trying to avoid politics is doomed to fail. Okay, so you don't avoid it, but you provide good governance, open governance. Okay, and so this is what the OpenStack Foundation is about. So the OpenStack Foundation basically has a governance model that specifies how all these companies can compete but also collaborate. It's a bit it's a bit similar to the Linux Foundation. You have many competitors collaborating on the Linux kernel, and this is how it works.
Any other questions? Okay, I have one.
Yes, go ahead.
Do you know why Python? Why choose Python to develop this?
Yes, so because the OpenStack project came about as a marriage of software that NASA wrote and of software that Rackspace wrote originally. So they merged so NASA had something called Nebula. Yeah, so it was called the Nebula project inside NASA, and Rackspace had like Swift, the object storage system, and they got to talk to each other and get to know about each other and merge these two pieces of software, and this is how OpenStack came into existence. And both these teams liked Python. Python was basically the weapon of choice for them. Yeah.
I have another one.
Yeah, go ahead.
What's the role of Rackspace in all of that, and how you're using it?
Yes. So the way this happened is, so something I didn't mention is that OpenStack is a very young project. It's like an infant. It's a small child. So it turned like 3 in July of this year. It's very, very young. Okay, and it has made great strides. So how this came about is that NASA and Rackspace said, yeah, we'll do this together. So NASA will contribute the compute part, and Rackspace will contribute the object storage part. Then NASA said, hey, I mean, sure, now we're done, because we're NASA, we're not interested in developing a cloud. We're interested in space research, space exploration. Okay, so I said, here you go, here's compute, have fun with it. So Rackspace basically had all this software on its hands and said, oh, this is a bit like like a kindergarten. Like playing alone is sort of boring. Okay. So what Rackspace did then is it established a foundation and transferred all of the intellectual property, i.e. all the software, into the foundation and said, look, we are really, really bored and we want you to play with us. Here's a foundation. Here's a brand new kindergarten. Come play with us. Okay. And then all these companies flocked into foundation, and this is how basically this came about.
Thank you very much. Oh, we have another question.
Yeah.
Hi. Well, OpenStack is, as you said, it's very fast-paced. It has updates every 6 months.
Mm-hmm.
How did you solve that problem when you actually set up your own OpenStack, like for example, Folsom?
Yes.
And then after 6 months, there's a completely new version.
Yes.
Of OpenStack. You already wrote some code for your own needs. You set up whole infrastructure. How it is even possible to update this so frequently and to keep the newest version in your infrastructure?
So the short answer to the question is no. We didn't solve the problem. Okay. So again, I'm going back to my statement that this is a very, very young project. Okay, and when I went to Portland and went to the OpenStack Summit, okay, so some of the most, bitterest complaints were, hey, there's no reasonable upgrade path. So you churn out all this brand new and cool software, but we're stuck. We don't know how to upgrade. Okay, and this is still unsolved. So it's very, very painful still to upgrade from one release to the other. It is improving slowly, but it will take some time until the project stabilizes. Right now, it is just a very fast-moving target.
One more.
Yes.
I may. When you develop the newest version, how soon it is actually production ready? I mean, there has to be bugs after release. It is impossible to just test everything.
Yes.
In development, and there are bugs. So do you even manage to fix the bugs from the previous version before you actually came out with new one?
Yeah. So I have a bit of insight how Rackspace. So Rackspace is running the biggest public OpenStack cloud today, and I have a bit of insight how Rackspace does things. So we basically have a team that is running and operating our cloud, and so what we do is we look at all the commits. Okay. And we're very selective, and we try to basically deploy the commits into production even before the official release. So we're a bit sort of preemptive and proactive in that respect. Okay. And so the other way to go about it is to have a staging cloud, or to stage a commit, stage an update in a part of your cloud, and see how it behaves. And if it holds up there, then deploy it on more machines, and then deploy it on more machines. Just deploy progressively. Okay. And as soon as you see things breaking, pull the handbrake, revert to the previous version. Yeah.
question actually binded to this. So,
Mhm.
if you want to sell the OpenStack solution to a carrier customer which needs a
Mhm.
carrier-grade solution,
Yes.
how you do convince them? As you said, okay, you are a customer of
Mhm.
OpenStack, and you need a staging and so on. How you convince a customer to actually use it?
It depends on the customer. I mean, again, this is a very young project, and what we usually recommend to our customers is to deploy an OpenStack cloud, okay, and then on that cloud deploy things that are not critical first, okay, because this allows you to learn. It allows you to learn how to deploy the cloud, how to bring up the cloud inside your organization first, then how to deploy things on the cloud, and while you go through the process, you know, all your staff, all your personnel will learn, okay, and then once you feel more confident, then you start sort of deploying more critical pieces on the cloud. Okay, but one big factor for many organizations is support. So, you know, Rackspace prides itself of fanatical support. So they basically say, you know, if there's anything, if you run into any kind of trouble, you know, we'll send out people there and we'll help you.
Thanks.
Mm.
Great talk, also. One question. You compared the OpenStack cloud to the Linux kernel.
Yes.
And currently I'm interested in an S3 compatibility. It's Swift, I think, in OpenStack, yeah?
Right.
So how monolithic the OpenStack cloud is? Can I take the Swift and, for example, one another component of the OpenStack and deploy the Swift only Swift, or is it a monolithic solution like a kernel?
So no, you can actually deploy just Swift by itself. So if you just want storage, you can deploy Swift just by itself. Yes, it is. Yeah. So there's a company called SwiftStack, and they're like a commercial company in the US, and they do this. This is their value proposition. They deploy just Swift for you. Is the question in the back?
Which Python version is OpenStack using for the code?
But it's 2.7, the newest 2.7. But like I know for a fact that all the tests run also on 2.6 and on 3.3. So like there's the ambition to cut over to Python 3 at some point. So the OpenStack development processes are very strict and very strong. So there's a very strong continuous integration infrastructure, and you know, testing is important. Code reviews are important. You need 2 core developers to review your code and to approve of it, so the code can land, etc. And so I just submitted a couple of patches myself, like a couple of weeks ago. And like when you submit a branch for review, what happens is that it first goes on the continuous integration server, and then Jenkins votes. Also has a vote on your branch. If all tests pass for all that Python releases, then Jenkins votes +1. And then this is usually the point at which actually the devs then start reviewing the branch. If it, you know, nobody looks at your branch until Jenkins says they can look at it. So 2.7 is the answer, but it's also tested on 2.6 and on 3.3.
Yeah, you mentioned the relationship between OpenStack and the public cloud.
Mm-hmm.
What about companies who cannot or will not use public cloud? How can OpenStack help them?
Well, again, it's a totally again it's a bit like Linux. You can take it and deploy it in your data center, and it's Apache licensed. So the investment you have to make is you have to learn about it, and you have to experiment with it. You don't have to pay any license fees or ask anybody for permission. So you can deploy OpenStack as your private cloud in your own data center, and you're good to go. Yeah.
Hi.
Hey.
You mentioned Linux.
Yes.
Do you use some Perl scripting?
I used to in my
on the project?
No, not the
Okay.
project.
And how fast you can deploy on like small cloud?
So there's another parallel to Linux. So Linux has distributions, distros.
That was my next question.
Yeah, and so OpenStack also has distros. So like there's an Rackspace distro that you can take and deploy. There's a Red Hat distro, and there's also like a bunch of Puppet modules, so which are maintained by like OpenStack people. So you can deploy an OpenStack cloud just by using Puppet, So it takes a bit of learning. You need to investigate, decide on a distribution, decide what you want to use.
Is it very custom distribution?
Say again?
Is it very custom distribution?
It's
much different from the...
No. Like I know like the Red Hat people, they wrote their own kind of installer, and the name escapes me now. But at the end of the day, they all install an OpenStack cloud, and you need to provide like some configuration to the process. And at the end of the day, what you end up with is an OpenStack cloud. So you need to basically learn OpenStack basics. And there's actually a book that is just whose second edition is just about to come out. It's called the OpenStack Cookbook. So which is written by Kevin Jackson. And if you are like contemplating of experimenting with your own cloud, I recommend reading the book and learning from that.
You say that every major company have their own version of it.
Well, not every, but like, so I know Rackspace has. I know Red Hat has, and Mirantis, who is the sponsor of this conference, I believe they also have their own installer equivalent. And then we have Puppet modules. Yeah. And another thing you can do is you can also like I believe Ubuntu also like has an installation mechanism for OpenStack. So if you're like running Ubuntu server, then you can use their installers. Mm-hmm.
Thank you very much once again.
Hey, thank you for all the good questions. Thanks.